supposing you are writing a really big code, you have so many thousand people writing the code, right? Now, definitely you will get so many functions, right? So how do you manage these functions? So think of it this way. So if we have many functions, something like this, let's say this is huge line of code, and then we break it into functions, right? Let's have different colors. Now we have too many functions. So how do we manage the functions? Any ideas, guys? Yeah, classes. But what do classes do? They simply just group the functions, right? So you look for the functions that look similar and you group them so that it makes your life a little bit easier. Does that make sense? Yes. All right. So the aim of classes is nothing more but to group your functions so that it's a little bit easier for you to manage a very large programming project. So in today's lab, our objective is to understand what classes are, what are objects, what is encapsulation, then what are instance variables, methods and constructors, and then we try to see how to implement all this information. Okay, so just talking will be boring. You have already seen that before. So let's try some coding. Okay, so let's say we have three functions. Let's say we have a function called addition, right? Okay, so addition, and addition will take two numbers, A and B, and it will add these two numbers and save it in C, and then return the value of C. Thank you very much. And then we have, let's say we have another function, division, which divide A by B. So we have C equals to A divided by B. And then let's say we return the value of C. Finally, we have another function. Let's call it what? Give me ideas, guys. Subtraction. Subtraction. So subtraction should subtract B from A. So we will have C equals to A minus B. And then we return C. Now, if you just run this code, now Python knows about all your functions. Straightforward. All we can do is just write. If I have two numbers, I can just say, okay, Z is equal to, and I can just do addition, and then I put one number in A and another number in B, right? Or make it a little bit fun. Let's have X equal to, we convert to integer and we ask the user to enter a number, right? So then we collect another number, right? So then we can simply say, okay, the first parameter gets X, thank you, and the second gets B. So if we run this code, what's going to happen? First, it will ask us to input x, a number, which will be saved in x. It will ask us to input another number, which will be saved in y, and then it calls addition. Addition is in line 1, right? So, addition is in line 1. So, a is the value of x is going to enter which of the variables in addition? A, and y will enter b. So if we run this, we can just print the value of z here. So if we run this, we have an error. What's the error? Aha, input. Thank you. Okay, so if we run this, it asks us for inputs, let's say 4 and 5, and it goes to addition, add up the numbers, return the value, save it in z, and we print z, right? Now, if we have so many functions, we can just put them in one box. Okay, we'll just have one big box and we put all these guys so that we don't lose one of them. So how do we do that? We put all this in a class, like we do with all you guys. So we put this in class, and we give the class a name. So we give it name, let's call it, what? Yeah, math is a poor choice because there is a math. Our own math will destroy the other one, and we cannot use the other one until we refresh the kernel. So we can add something a little bit to the math. Maybe you can call it, okay, let's call it op math, operation math. Okay, so op math has operations for, okay, so it has operations for all these additions and subtractions. So to put all these things inside the class, what do we do? Barakallahu feek. We're becoming an expert. Yeah. Maybe next class we'll just take over. Yes?
How did you make the indentation for the whole?
I just highlight everything and press tab. So it
when you use tab, it removes the code.
It does if you mistakenly press the delete, the insert key right near delete.
No, I enter the tab.
Yeah, maybe when you are typing, you press insert by accident, you didn't know. So now, anything you try to modify, the computer is going to clean it. So if you want to, if your computer is misbehaving like that, just press the insert again. It will come back to me. Yeah. If it doesn't work, just contact me on Teams and we will solve it. Okay? So we have op math. Now, look at what happens. Let's refresh the kernel. Sorry. Okay. So let's refresh the kernel. So let's refresh the kernel from this so that things look new. And then let's try running this code again. So now if you run the code, now we have created the class, right? Now if we try here, it will ask us to insert some numbers, 4, 5. You can see I'm having an error because the computer is telling me that it doesn't know addition. Why? Yeah, the problem is we have taken this addition. Just assume this is addition and subtraction, right? And which one else? Division, barakallah. Division. And what did we do? We put them inside a box. Let's make the box purple. So we put them inside this big box. And what's the name of the box? Opmath. Barakallahu. Yeah. So the class is called Opmath. So the only way I can access these things is if I go through the class, because now they are inside a box. Okay, so the only way I can access them is go through the box. So how do we do that? Well, the first thing, what you just did, putting everything inside class, is called encapsulation, because now you are hiding your functions so that you cannot use them directly unless you go through the class. Encapsulation is the same word used for capsules. How many of you have seen the capsule? This one the doctor gives you if you are sick. It looks like plastic, and inside the medicine is inside. Sometimes the medicine is too bitter or it's not good for your mouth, so they put it in a plastic. So when you swallow it's not a dangerous plastic. I don't even know what type of material it is, but it looks like plastic. Sugar. Yeah, something like that. It shouldn't be something that will kill you. So if you swallow, it dissolves, and then the medicine comes out of it. So the same word, encapsulate. You are just hiding all your functions inside a box. Unless you can access that box, you cannot see the functions. Okay? So let's go back. Now, so how do we solve this problem? We have to create an object. That's what we will do. Thank you. Opmath dot. But this is how you do it. What you will do is, I will show you how to do what you are planning to do. But for now, what we want to do is we want to take a copy of this object that we have, the class, and create an object with it. So this is how you do it. You can just say, okay, P1, or let's call it variable 1, is equal to opmath. Simple. Now you have created an object called var1. What you are simply doing is you just come here. What you simply did was you come here and you created a variable called var1, and you went to the class and you made a copy like this. Then you come here and paste it as var1. So you just take the box, copy it, and take that copy and give it a name var1. So everything that the class has, var1 has it. So we will keep the class, the original copy, and then we will keep making copies of it. You can make as many copies as you want. Does it make sense? Yes?
Can variable 1 contain many classes?
Many functions. The class opmath, it can have as many classes as possible.
I mean, many classes.
Yeah. No, you can't add more than, it's like, if you remember, I said this is equal to this. If I have a variable x equal 3, 3 is an integer, right? And then later in my code I say x equal 5. What's going to happen to the 3? It will be thrown away and the 5 will take its place. So if you try to put another class inside var1, the old one will just go. Okay? Alright, so now we have this process of creating the object is called instantiation. You just instantiation, instance, at once, just like that. Right? So instantiation, that's what we just did. We copy the class and make an object out of the class. Okay? So then now, since you have this, you can easily do this addition again. How do you do it? Exactly. Opmath. But we said opmath is the same as what? var1. And if you remember, we said we don't want to use opmath because we want to keep the original clean. So that anybody who comes can use it to make a new copy of Barakallahu Feek. So it will be var1 dot addition. Okay? And this will access the addition. It will send x and y to a and b, do the addition, and bring back the value to z. Okay? So if you ask for input, we will get an error. Why? See, what we said previously is that I use the class to make a copy, right? So that means I can create another copy var2, isn't it? Of the same object, isn't it? I can make as many copies as I want. So if I say something like var1 dot addition, when the computer goes inside this box, it gets confused whether it is inside the box for var1 or it is inside the box for var2. We have to have a variable that will help us differentiate the two boxes. Okay, so what they did in Python to come up with a solution is that whenever you say var1 dot addition, Python will automatically send the address of var1 along with the x and y, so that you can differentiate all the copies you have made.
So it's independent.
Yeah, it's silently doing it for you. But unfortunately, I don't know why they did that. You have to collect the address yourself. You hear the word yourself somewhere in my word? So that's what we will use. So here, we'll just add the keyword self. Now what happens is, when you say var1.math, even if you have var2, var3, and so on and so forth, the address for var1 will enter inside self, so that the Python will know which of the objects you really want to use. Do you understand? Because it has, okay, remember it has so many copies here. Each one is saved in the memory. So let's say this one is called number 1, and this one is called number 2. Just to differentiate, because they look exactly alike. Okay? So how to, now we know this is 1, this is 2.
But they already have the name var1, this is var2.
Exactly. But inside the object, there is nothing that differentiates them, right? The good thing is we have var1 and var2 to differentiate for us, the programmers. But in reality, this var1 is this identifier, this number. So think of it this way. Thank you for that.
So var is for the programmer, the 1 is for
the 1 is for the computer. But let's assume even the computer is using the var1. Just to make life easy. Let's assume even the computer is using var1. So this var1 is sent to the class. It's sent to the compiler along with x and y, so that the computer knows I'm going to use var1, not var2. So you need to add this self in your classes to collect that var1. Okay, so you are not going to use it for your own use. You are going to collect it just for the class to know which of the variables are used. Yes.
So we will use var1 with along with x and y.
Yes. Let's turn off this. So remember, X is going to A, Y is going to B. Right? The var1 itself is going to enter self. This will help the computer avoid confusion if I have var2, var3, var4, and so on and so forth.
So every variable, var1, var2, var3, have its own variables and its values?
Exactly.
Oh, okay.
That's why we have the objects, so that you can make many copies of them, and in some kind of programming magic, you can even make them run at the same time. That's how you are able to play video game with all your friends from different parts of the world. Yeah.
So when I write addition,
yeah,
I don't need to write inside the argument var1.
Yeah, you don't have to do that. Why? Because everybody is making a copy of this original class. Okay? Everybody is copying this class. But because the class look exactly alike, the only way we can differentiate whose class we are talking about is if we send the name of the object that we are using. You understand? So this name, we always keep it inside self. Because in the computer, we make so many copies of the class. Whenever you are going to use the class, you need to send the name or the address of that object that you make. Okay? Yeah.
When I make a new copy, should I put it in the original definition?
When you make new copies, can you do what?
For example, var2.
Yeah, var2. Let's add var2. Let's say equal to Okman. So we have created two copies now, just like we did here. So we have two copies. One of the box we label it 1, and the other box we label it 2. Okay? So what are you trying to say? So this place, you can think of it like the cell. That number that identifies which of the boxes you are currently talking about. The word self means nafsi, right? Myself. So if we are twins and we look alike, you may confuse me and give my friend my money, right? But if I have bigger ears than my brother, you can have an ID to differentiate me from him. So in this case, what we have is this number, this one, the self. Okay?
It's 1 and it's 4.
I think his mom will not be happy with you. Okay. So, any questions so far? The self is just the address that allows us to differentiate all the copies of many classes that we have made.
So why did we get error here?
We get error because if you look at the message down, it's telling you you have only 2 arguments. Addition needs 3 arguments.
So I have var1.
You have to have self. Yeah, you have to have self here. Because the Python is secretly sending var1 to the class. You understand? So that's why it is telling me, why are you giving me x and y only? I need 3 arguments. The third argument is the name of the object or the address of the object itself. Okay? So that's why we add self. So for that case, we have to add self for this. Okay? And this. Okay? For the same reason, so that the computer can differentiate which object we are talking about. Now, if you try running this, let's call, so we have z for x and y. Let's have p for, if we say ba2 dot addition, but this time around we have 3 and minus 1. Okay, so if we print z, then we can print p here. Okay, so if we run this, we are asked input 4 and 5 as usual. Oh, I have not updated the class, right? Run, then run this. Yes?
If you change the order of the print last statement,
Yes.
yes, will the values change in print C and print P?
Yeah, of course, because I'm just remember when I said var1 dot addition, I'm sending the values for x, for y, and I'm sending them. So what I did is I am sending 4 and 5 to this guy. So I'm sending 4 and 5 to this addition for var1, and I am sending 3 and minus 1 to var2. So what I'm doing is I am sending 3 and minus 1 to the other object. So if you are doing parallel computing, they can even run at the same time. They will print you their output at the same time if you want. So these two guys are independent, right? Because they are two different boxes. Okay? Any question? So this is how it works. Now you can do something, right? What we can do is this. So these guys, these functions, these three functions are what you call the methods. They are just functions, but we like to call them methods so that we confuse the managers and they pay us more. And now they are coming to our classes, so we are in trouble.